This is an instructional video on solving multi-step problems involving exponents. It's important to remember that for this video, we are going to be using all of the shortcut methods that we learned in all of the past exponent lessons for multiplying exponents, dividing exponents, raising to a power, zero exponents, and negative exponents. For this problem, I can quickly see that we're going to have a raising to a power, a dividing, and a negative exponent. So we have three pieces to solve, and we solve them one at a time. When we are raising to a power, we know that we need to multiply our exponents. So in this case, we're going to do 2 times 5 to get 10. I'm going to rewrite the problem. We now have 7, we keep that base number, to the 10th power, divided by 7 to the negative 6th power. Now we are dividing, this fraction bar means divide, we are going to subtract our exponents. So 10 minus negative 6. 10 minus negative 6 is going to give us 16. Keep our base number the same, 7 to the 16th power. For this problem, again, we have a dividing bar, we have a raising to a power parentheses, and we have another division symbol. So we are going to go one step at a time, do the raising to a power first, get rid of that multiplication. When we raise to a power, we multiply 2 times the negative 3, which is going to give us negative 6. Once you do each step, you need to rewrite the original problem. So we still have the 4 to the 8th. I have 4 to the negative 6 on the bottom, and we still have the dividing by 4 to the 4th out to the side. The fraction bar means divide, so we're going to go ahead and subtract our two exponents, 8 minus negative 6. 8 minus negative 6 is going to give us a positive 14. So again, we rewrite the problem. 4 to the 14th power divided by 4 to the 4th power. Still dividing, so we're still subtracting our exponents. 14 minus 4 is going to give us 10. Keeping that base number 4 the same, 4 to the 10th power is our exponent. In this case, this n variable up here at the top would be a 10. Looking at this problem, I see a division symbol, I see a fraction bar, which means dividing, and I see parentheses, that means multiply. Start with the part that looks most complicated. The largest section is up on the numerator on top where we're multiplying, so we are going to add our exponents. 8 plus negative 4. 8 plus negative 4 is going to give us a positive 4. We bring everything else down, rewriting the problem. 13 to the 6th divided by 13 to the 4th, that's our new part, and keeping the denominator 13 to the negative 2nd the same. Our next step, that fraction bar means to divide, so we subtract our exponents. 4 minus negative 2. 4 minus negative 2 gives us a positive 6. We end up with 13 to the 6th power divided by 13 to the 6th power. We're keeping those base numbers the same. Again, we have another dividing problem, so again we are subtracting our exponents. 6 minus 6 is 0, 13 to the 0 power. And we know that anything to the 0 power is 1. Our final answer is 1. For this problem, we have a raising to a power because we have double exponents on top, and we have a fraction bar, which means we're going to divide. So when we start with raising to a power, we start by multiplying our exponents. 3 times 2, which is going to give us 6. Rewrite the problem. Base number 2, exponent 6, with 2 to the 5th power still on the bottom. When we're dividing, we subtract our exponents. 6 minus 5 is going to give us 1. And so our final answer is going to be 2 to the 1st power. Looking at this problem, I see a fraction bar, which tells me to divide, and I see a multiplication symbol, so we are going to multiply. One step at a time. When we are dividing, we have to subtract our exponents, so 4 minus negative 8. 4 minus negative 8 is going to give us a positive 12. Keep the base number 4 the same, 4 to the 12th power, and bring down 4 to the negative 14th power. This time we're multiplying. Multiplying means we add our exponents, 12 plus negative 14. 12 plus negative 14 is negative 2. Keeping that base number the same, 4 to the negative 2nd power. We know that negative exponents have to be written as a fraction, so the base number and the exponent go down on the denominator. They go down to the bottom. There's nothing else remaining in the problem, so we leave it with a 1 in the numerator on top. 1 over 4 squared is our answer. For this problem, we can look and see we are raising to a power because we have double exponents, and we're also multiplying as per the multiplication symbol. Start with the raising to a power where we multiply the exponents 2 times 6 to get the exponent 12. Then rewrite the problem. 5 to the 12th power times 5 to the negative 9th power. We're multiplying, so in this case we're going to add our exponents. 12 plus negative 9 is going to give us a positive 3. Keep that base number 5 to the 3rd power.